Greetings and welcome, friends. Today is a new day. We're going to talk about the law of sines, which is a technique for solving non-right triangles. That's right. Every wrong triangle that could never be solved, well, not everyone can be solved with the law of sines. We'll use another technique for some of the other ones. But we're going to talk today about solving the non-right triangles, obtuse, acute, etc. So let me draw a picture. Imagine a non-right triangle. All right, so this is a not 90-degree angle up there. It's actually sometimes hard for me to draw a non-right triangle. Here's angle A, here's angle B, here's angle C. Okay? And by default, little b is here, little c is there, little a is there. Now, if I want to prove this law of sines to you, I'm gonna show you this relationship here. Let's draw. Now there's no right angle, so all of my trig ratios are kind of broken. I can't use sine of 30 degrees or sine of theta or angle A or B unless I have a right triangle. So I'm going to make a right triangle out of this. I'm going to draw a height. All right, so here's H. And since it's a height, it's obviously perpendicular to one of the sides, the opposite side from the angle of which it dropped from, right? And now I've got a right triangle. I can draw some relationships from this. So for instance, from angle A's perspective, the height is the opposite, right? And the side length B is the hypotenuse. So what trig ratio compares the opposite to hypotenuse? Sine. And I hope so, considering today's lesson is about sine. So I could say that sine of angle A is equal to H over B. Okay? So this, by the way, is our little proof or derivation of the law of sines. And I haven't even given it to you yet, so we're kind of discovering it simultaneously here. Let's look at the same situation from angle B's perspective. So these are not congruent. And from angle B's perspective, what is H from angle B's perspective? What side? It's the opposite. And little a is the hypotenuse from B's perspective for this little right triangle to the right of the triangles here. So I could say, oh, wait, opposite hypotenuse. That sounds like sine. So I'm going to say that sine of B is equal to H over A. I want to point out here that side C is the entire length across and not just, like part of it. So that's not the case. It's the whole length across. But we're not even going to use that for now. Now what I've got here are two equations and technically a bunch of unknowns. But I'm going to do a little bit of handy-dandy work on these. I'm going to solve both of these equations for H. So to do that over here, to get H by itself, I'm going to multiply by B. And to do that over here, I'm going to multiply both sides of this equation by A. So that's going to give me B times sine of A is equal to H. And this is going to give me A times sine of B is equal to H. So if both of those are equal to H, according to substitution, what do I know? If this is equal to H, I could then plug this in over here, and these two things are going to equal each other, right? I could also actually make that claim using the transitive property of equality. If this is equal to H and H is equal to that, therefore they're equal to each other. A equals B and B equals C means A equals C, right? So B sine of A must equal A times sine of B. And technically I could say here is a law of sines, but mathematicians were like, meh, let's change this a little bit. They decided to divide both sides by little a, just to rearrange it, make it look a little nicer. And they'd get B times sine of A over little a is equal to, those little a's cancel out, that's just sine B. And then they decided, hey, we might as well move this little b while we're at it, so they divided both sides by little b. so that these would cancel out. Just to get the A's and the B's together, they figured, hey, they look like they should be friends. So they decided that sine of A over little a is equal to sine of B over little b. And this is true. We've just proved it. All right, so this is part of the law of sines. And if I used a similar setup, all right, by similar outcomes, if I dropped my height from one of the other angles, all right, or even if I just renamed my triangle and this was the C and this was the B or something, I could come to a similar relationship regarding angle C related to angle A or B. All right, so the law of sines looks like this. And there's actually a couple ways of writing it. I could say that the sine of angle A over little a is equal to the sine of angle B over little b is also equal sine of C over little c. All right, so this is the law of sines. And if I wasn't a fan of putting angles in priority over sides, I could also have the reciprocal version of this, where I just flip it. So I could do little a over sine of A equals little b over sine of big B equals little c over sine of big C. So depending on which I'm looking for, if I'm looking for an angle, I'd use the top relationship. If I was looking for a side, I'd use the bottom relationship. They're really the same exact thing. They're just kind of one step logically apart from each other. All right, and what's nice about this is notice none of these have the variable h in them, right? If I go back to what my original sketch was, they're all just related to the angles and sides of some non-right unknown angles triangle, right? So it's actually really good for us. That means we can now start solving non-right triangles. And I'll show you how. I'm going to do a couple examples today. Let's consider an obtuse triangle. And let's say I've got a 104-degree angle and a 32-degree angle. And let's say opposite the 104-degree angle is a side length of 10. Now, technically in the real world, most problems are not given to you with variables and letters attached to them. So if we want, we could label this. I could make the 104 angle A, I could make the 32-degree angle B, and this little c. And then the rest of the labels follow suit. So one of the things I want to point out about the law of sines is it's only effective if I have at least one pair of angle and side. Okay? Notice I need to know an angle A and its side, or an angle B and its side, right? Or an angle C and its side. So it wouldn't be helpful if the side I knew was the one in between them, in fact. That's one of the law of sines' weaknesses, I might say. But don't worry, it's got a good friend, a good buddy that'll come along in a couple lessons. He'll be able to save the day in those situations. So we're fine. We're good. Well, actually, in that situation, if I had angle, side, angle, I could just find this angle first and then go opposite. But anyways, there are situations in which law of sines won't apply. But fortunately tonight, hopefully they only apply. So do I have an angle and its side pair, right? I've got A and little a, right? So that does work out. So I'm going to, actually, what's the first thing I could find? I've got A and little a. I've got angle B, so I should probably find little b first. That makes sense, right? Because according to the relationship, that's the only next thing I could find, unless I wanted to find angle C first. I suppose I could do that. So let's find little b. So because I'm looking for a side, I'm going to choose this ratio, where I'm going to put the side that I'm looking for in the numerator, rather than this way, because then it's in the denominator. It's really just a matter of preference. You wouldn't be wrong doing it the other way. Just add a step of work for yourself. So I'm going to say b over sine of angle b, or 32 degrees, is equal to 10, right, that's side A, over the sine of angle A, sine of 104 degrees. So if I want to solve this for little b, it's currently being divided by sine of 32. How could I get rid of that sine of 32? Multiply. So I'd multiply both sides by sine of 32 degrees, right? And I'll get little b is equal to, and I might write it this way, 10 times the sine of 32 over the sine of 104. And I'm just writing it to you this way so you can see how I'd plug it in a calculator. Technically, you could have the 10 in the numerator if you want. A bunch of different ways you could do that. So let's figure this out. So be careful with your order of operations in your calculator if you have to. So 10 times the sine of 32, close parentheses, divided by the sine of 104, close parentheses, and I get b, little b, is equal to 5.46. Behold, we've just found the side of a non-right triangle. How great is that? So that's what we've just done. Now, the next two pieces of information I need to find if I'm solving this triangle is angle C and little c. Now, question, I've got two side lengths here. Can I use Pythagorean theorem to find little c? No, why not? Because it's not a right triangle. Pythagoras has failed us. Oh, terrible. But what I can find is angle C is the next angle that I could find, or the next thing I could find. Right? So to find angle C, what would I do? Yeah. So C is going to equal 180 minus the sum of A plus B. Right? Triangle sum, all of those add up to 180, so I'm just going to do 32 plus 104 is 136, subtract that from 180, and I get 44 degrees. Okay, but now how am I going to find side C? Well, I could use law of sines again. I'll do little c over the sine of 44. Equals, and now I technically have a choice. I could compare it to the ratio of b's, little b to angle b, or a's, little a to angle a. I'm going to choose a in this case because that's the one that was given to me. All right, I mean technically I also used that information to have. Oh no, I didn't use that information to lead to angle C. So yeah, I'm going to use it, the given information in case, what if I made a mistake in finding B? I'd rather avoid it if I could. You wouldn't be wrong for doing that. You're just taking the risk that what if you were wrong and now you're spreading your wrongness. So that's 10 over sine of 1 over sine of 104 degrees. And now I could solve this. Similar approach. Get C by itself. I'm going to just multiply both sides by sine 44. And I'll get little c is equal to 10 times sine of 44 degrees over sine of 104 degrees. So little c is equal to 10 times sine of 44, close parentheses, divided by sine 104, close parentheses, and I get 7.16. Right? So it's not that bad to use it. There is some choice involved of picking, what angles and sides to relate. But if you actually look at it, there's only one sequence that I could have solved these in. For instance, I could have found angle C first, I suppose in this case. But I could not have found little c first, for instance. But yeah, so I mean, you just try to figure out what information do I know, which of these, what two do I want to compare. That's going to help me solve another piece of information based on what I have. Okay, so that's the idea. So let's look at one more example. In this one I had angle, side given to us, and it was able to work there. So let's say I have a triangle that looks like this. Here's an acute triangle. Let's see, something like this. And let's say this is 80 degrees, and this is 5, and this is 7. So this is technically a kind of angle side situation. We'll analyze these in further detail tomorrow in the next lesson. So I'll label these, doesn't technically matter, A, B, C. So question, can I use law of sines? Do I have an angle and its side buddy? Yes. I've got angle A and little a. Okay? I also have little c. So what's the next piece of information I could find? Angle C, right? So I'm going to set up a relationship of sine of angle C over little c, which is 5, equals sine of angle A, which is 80, divided by side A, which is 7. Now, why did I choose the angles over the sides this time, do you think? Because I'm trying to find the angle, so I'm trying to make it easier for us.
I'm going to have doctor at 10:30, so I might not be back. These are the two things. This is going home in the newsletter, and this is a rubric thing I want to get, polish it up more.
Yeah. So if I'm now trying to find angle C here, how do I get angle C by itself? Multiply both sides by 5. Right? So that would give me sine of C equals, I could call this 5/7 times sine of 180. There's a bunch of different ways you could arrange this. 5 times sine of 80 all over 7, whatever you'd like. And now here's the question. Let's see how well you know yesterday's skill. How do I get C by itself?
Inverse.
Sine inverse, both sides. Sinverse. So I get angle C is equal to, right, the sine inverse of 5/7 sine times, or sine of 80 degrees. All right, so to plug that in my calculator, I'm going to have to be very particular. It's out of focus, guys. Let's see, so sine inverse, that is not focused, calculator. Shame on you for even calling it that. Man, it is not trying very hard. All right, here we go. One more shot. Otherwise, I'm just going for it. Trying to give it something of contrast to focus on. All right. One more shot after the last shot. Here we go. Maybe it'll focus on the text. Oh, it's looking good. It's looking good. And we're good. All right. So I want to enter in sine inverse. I'm going to hit second sine inverse of, what was it, 5/7?
Mm-hmm.
Yep, so 5 divided by 7 times the sine of 80 degrees. All right, and I need to close the parentheses on the sine of 80, and I have to close the parentheses now on the sine inverse. Okay, just so that the calculator understands what order I'm doing this in, I'm going to hit enter, and I got 44.7. 44.70. Right, not bad. So there's my angle C. And now that I know that, how could I find, what's the next piece of information I could find? Angle B. And angle B is just going to equal 180 minus A plus C using triangle sum theorem. So that's going to be 180 minus the sum of 80 plus my second answer on my calculator. Just to show you I plug that in, being clever. Right, I put parentheses around that 80 plus second ant, so I'm actually getting all the decimals there and don't have to re-enter them. So 55.7 What do I round that up to if I want 2 decimals? 30. Without the 0, you technically aren't communicating if you round it up to 3 decimals, or 2 decimals, sorry. 55.30. So there's angle B. And now, how do I find little b? I'm going to use the little b over, right? So I'm using the flipped version of the sine law of sines, right? Little b over sine of my angle b, the 55.30, equals, and I might as well compare it to the a's since that's what was given to me. So that's, what was it, 7 over sine of 80. And we're just about out of time. I've got a minute left. I'm going to keep rolling with this. So you guys can leave in the minute when it happens. But I'd multiply both sides by sine 55, right? And I'd get little b is equal to 7 times sine of, 55.30 over sine of 80. So little b is equal to 7 times, I'm going to actually be able to enter sine second answer, close parentheses, divide by sine of 80, close parentheses, and I get 5.84. And as one last thing you could do is actually compare, is your largest side opposite the largest angle? Is your smallest side opposite the smallest angle? Just to kind of verify, does it make sense according to the sketch? And I believe it does in this case. So thanks for watching, Internet friends. Have a great day. Bye-bye.